Let's say that you and your friends decide to have a picnic. Then one of you would bring the food, one of you would bring the drinks, and another friend brings a speaker. Once on the picnic, you guys combine the skills and knowledge to make it more fun. If you organize the entire picnic by yourself, you probably would have to do a lot more work and it would have taken a longer time. A grid computing system uses that same concept: share the load across multiple computers to complete tasks more efficiently and quickly. Hello, I'm Shobhitaa Barik from Bennett University, and in this video I'll be explaining the concept of grid computing. Grid computing is a computer network in which each computer's resources are shared with every other computer in the system. Let's take a quick look at a computer's resources. There's the central processing unit, or in short, CPU, which is the brain of the computer, where most calculation takes place and the data is directed to different memory locations. A computer's memory is a kind of a temporary electronic storage. Memory keeps relevant data close at hand for the microprocessor. Without memory, the microprocessor would have to search and retrieve data from a more permanent storage device such as a hard disk drive. Storage. In grid computing terms, storage refers to permanent data storage devices like hard disk drives or databases. Usually, a computer has a limit of how fast it can perform an operation or how much information it can store. Sure, it is possible to add more power or capacity to a computer, but that is just an incremental increase in its performance. Grid computing systems link computer resources together in a way that lets someone use one computer to access and leverage the collected power of all the computers in the system. To the individual user, it's as if the user's computer has transformed into a supercomputer. A grid computing system requires the following things: at least one computer which acts as a server which handles all the administrative work for the system. You can refer to this kind of computer as a control node. The control node must prioritize and schedule tasks across the network. It's the control node's job to determine what resource each task will be able to access. The control node must also monitor the system to make sure that it doesn't become overloaded. It's also important that each user connected to the network doesn't experience a drop in his or her computer's performance. A collection of computer software called middleware. The purpose of middleware is to allow different computers to run a process or application across the entire network of machines. Without it, communication across the system would be impossible. A network of computers running special grid computing network software. These computers act as a point of interface for the user as well as the resources the system will tap into for different applications. There are two types of system in grid computing network systems: a homogeneous system and a heterogeneous system. In a homogeneous system, the operating system of all the computers in the grid computing network system is the same. In a heterogeneous system, the operating system of the computers in the grid computing network system is different. The network can be anything from a hardwired system where every computer connects to the system with physical wires to an open system where computers connect with each other over the internet. Since you're linking two or more computers together, you have to prepare yourself for certain questions. How do you keep personal information private? How do you protect the system from malicious hackers? How do you control who can access the system and use its resources? The middleware and control node of a grid computing system together control how much access each computer has to the network's resources and vice versa. While it's important not to let any one computer dominate the network, it's just as important not to let network applications take up all the resources of any one computer. Complete access is given only to certain users for security purposes. Most systems have authorizations and authentication protocols. These protocols limit network access to a select number of users. Other users are still able to access their own machines, but they can't leverage the entire network. With this, I conclude my video and I hope you liked it. Thank you so much for watching.